So in the last class, we have discussed about Henry's law. If you remember, Henry's law was applicable for the solution of gases in liquids. Now we have one more law which is called as Raoult's law. Raoult's law anta innond law barutte. This law applies majorly for the solution of solid in liquid and liquid in liquid. So in the beginning itself, I have mentioned we are studying mainly focusing on the liquid solution. That means the solution in which solvent is in liquid state. There are three types of solutions. One is gases in liquid, solids in liquid, liquids in liquids. Gases in liquids other solubility now with the help of Henry's laws we have studied. As pressure increases, solubility also increases. Here we have two more types of solutions, that is solid in liquid solutions and liquid in liquid solutions. There comes a concept known as vapor pressure of liquid solutions. What is vapor pressure? We shall see in detail. The liquid solutions are formed when the solvent is in liquid state. The physical state of the solution is decided by the solvent. When solvent is in liquid, the overall solution will be in liquid only. Adike illi highlight ಮಾಡಿಟ್ಟಿದ್ದೀನಿ. Solvent is a liquid phase. Okay. The solute can be a gas or liquid or solid. But here we shall study only the solutions of liquids in liquids and solids in liquids. Gases in liquids ಬಗ್ಗೆ ನಾವು already ಕಲ್ತಿದ್ದೀವಿ. Remaining two are liquids in liquids, solids in liquids. Solutions may contain one or more volatile components. Generally, the liquid solvent is volatile. In a solution or in a binary solution which contains two components, they are volatile in nature. Usually, solvent is volatile. Volatile antandre enu? The solution which gets evaporated at room temperature are called volatile solutions or volatile solvents, solutes, anything. The component which gets evaporated at room temperature are called volatile substances in nature. Volatile ಅಂತಂದ್ರೆ ಇದನ್ನ ನೆನಪಿಟ್ಕೋರಿ, room temperature ಅಲ್ಲಿ evaporate ಆದರೆ ಅದಕ್ಕೆ volatile ಅಂತ ಹೇಳ್ತೀವಿ. Let us consider a binary solution of two volatile liquids. Two liquids, that is liquids in liquid solution ಒಳಗಡೆ two liquids which makes a binary solution and both are volatile in nature and denote the two components are 1 and 2. For instance, we consider two solutions of volatile solvent, volatile components. When taken in a closed vessel, both the components would evaporate and eventually equilibrium would be established. Since they are volatile in nature, they get evaporated easily, both the components. Haudala? At this stage, vapor pressure will be P total. We consider P total. Let us denote P total as the vapor pressure of the overall solution, and P1 and P2 be the partial vapor pressure of the two components. Partial vapor pressure of the two components. Now what is vapor pressure? The vapor pressure antandre enu? Pressure exerted by the vapor in a given system is called vapor pressure. Pressure exerted by the vapors is known as vapor pressure. The partial vapor pressure of the two components, these partial vapor pressures are related to mole fraction x1 and x2 of the two components 1 and 2 respectively. According to Henry's law also we have discussed, but here also we will consider x1 and x2, that is mole fraction of two components. Then according to Raoult's law, who was the first scientist to observe these behaviors of liquid solutions, he gave a explanation which is known as Raoult's law, and it states that for a solution of volatile liquids, this is important, for a solution of volatile liquids, solution which contains two volatile components, for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction in the solution. I repeat, for a solution of volatile components, the partial vapor pressure of each component in a solution is directly proportional to the mole fraction of that component in the solution. That is P1. P1 anna partial vapor pressure of component 1 anta ತಗೊಂಡಿದ್ವಿ. Therefore P1 is directly proportional to x1. x1 is mole fraction of component 1 according to Raoult's law. In order to remove this proportionality constant, P1 is equal to P01 into x1. P01 is nothing but vapor pressure of pure component at the same temperature. ಆ ಕಂಪೋನೆಂಟನ್ನು ಪ್ಯೂರ್ ಕಂಪೋನೆಂಟ್ ತಗೊಂಡಾಗ ಎಷ್ಟು ವೇಪರ್ ಪ್ರೆಷರ್ ಇರುತ್ತಲ್ಲ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ P01. ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಮಿಕ್ಸ್ಡ್ ವಿತ್ ಅದರ್ ಕಂಪೋನೆಂಟ್. ಬೈನರಿ ಸೊಲ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಎರಡು ಕಂಪೋನೆಂಟನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿರ್ತೀವಿ ಆ್ಯಂಡ್ ಈಚ್ ಕಂಪೋನೆಂಟ್ ಸಿನ್ಸ್ ಇಟ್ ಈಸ್ volatile in nature, it has some vapor pressure in its pure state. In its combined state also it has some vapor pressure. That vapor pressure is P1. In pure form it has vapor pressure, that is it's P01 ಅಷ್ಟೇ. P1 is equal to P01 into X1. Similarly for component 2, P2 is equal to P02 into X2 according to Raoult's law. Then P total is given by, since P total is the total vapor pressure of the solution in the given system, P1 plus P2, partial vapor pressures of component 1 and component 2. ಎರಡನ್ನು add ಮಾಡಿದ್ರೆ we will get the P total. P total is equal to, from this equation, if you write this as equation number 1, this is equation number 2. From equation 1 and 2, you will have P total equal to X01, X0 into P01 plus P02 into X2. 1 minus X2 into P01 after rearranging. ಯಾಕೆ ಇದು 1 minus X2 ಯಾಕೆ ಬಂತಿಲ್ಲಿ X1 ಅಂತಂದರೆ, because we know the relation of mole fraction, ಏನು X1 plus X2 will be always equal to 1, so that X1 equal to 1 minus X2. ಹೌದಾ, ಇದೇ ರಿಲೇಷನನ್ನು ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. 1 minus X2 is nothing but X1 plus X2 into P02. So after rearranging, P01 plus P02 minus P01 into X2. Here we have, observe madri, only one mole fraction we have. Mole fraction of component 2. 1 illa. Mole fraction of component 1 is not here because we have rearranged with respect to X2. So following conclusions can be drawn from this equation. What does this equation implies? ಏನು ಹೇಳುತ್ತದು? Total vapor pressure, ನೋಡಿ, total vapor pressure over the solution can be related to mole fraction of any one component. As I told here, in the final equation we find only mole fraction of one component, that is component 2. If you write X2 in terms of X1, you will get only one component mole fraction. Andre that is the conclusion. Total vapor pressure is a function of mole fraction of any one of the component. Since it is a binary solution, ಯಾವ್ದಾದ್ರು ಒಂದು ಕಂಪೋನೆಂಟ್ ಇದು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಅಷ್ಟೇ ಅಪ್ಲೈ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಒನ್, ಸೆಕೆಂಡ್ ಒನ್, the total vapor pressure over the solution varies linearly with the mole fraction of component 2. See here, P total is directly proportional to X2. As X2 increases, P total should also increase because it is directly proportional. This is one more conclusion from this equation. Third one, depending upon the vapor pressures of the pure components 1 and 2, total vapor pressure over the solution decreases or increases with the increase of mole fraction of component 1. X2 related, P total always increases, but X1 related, in another component, if you consider mole fraction of another component, it may decrease or increase. These are the three conclusions made out from Raoult's law, this equation. So it is depicted in the graphical representation also. Here, see, these lines, these dotted lines represent partial pressure, vapor pressure of component 2, that is P2. This is vapor pressure of component 1, P1. See here, if you observe, X2 is 1, here X1 is 1. ಅಂದರೆ ಈ ಕಡೆಯಿಂದ ಈ ಕಡೆ ಹೋದರೆ X1 is 0 to 1. ಇಲ್ಲಿಂದ X2 is 0 to 1. See, X2 increases. X2 value along the x-axis it is increasing. ಇಲ್ಲಿಗೆ 0 ಇತ್ತು, ಈ ಪಾಯಿಂಟಿಗೆ ಬರಬೇಕಾದ್ರೆ X2 is 1. Therefore, as X2 increases, P2 also increases. X2 increases, P2 also increases. ಹೌದಾ, ಈ ಗ್ರಾಫ್ ಉಲ್ಟಾ ಬಂದಿದೆ. ಯಾಕೆ? ಬಿಕಾಸ್ X1 is 0, therefore P1 is also 0. X1 is 0, here X1 is 1. ಅಂದರೆ X1 is increasing this direction, in this direction, therefore P1 is also increasing in this direction. As X1 increases, P1 also increases because it is directly proportional. From the last equation, see, P total is function of any one of the component. That is why it should be directly proportional. This is P total. P total ಅಂತಂದರೆ P1 plus P2. It is given by number line 3. This is the graph. The plot of vapor pressure of 1 mole fraction of an ideal solution at constant temperature. The dashed lines 1 and 2 represent partial pressure of components 1 and 2 respectively. It can be seen from the plot that P1 and P2 are directly proportional to x1 and x2. Just now I told you, as x1 increases, P1 also increases. As x2 increases, P2 also increases. It is directly proportional. From the Raoult's law, P is equal to P1 is equal to P01 into x1. It is directly proportional. How the partial vapor pressure. The composition of vapor phase in equilibrium with the solution is determined by the partial pressure of the components. This is the conclusion. Then we have one in-text question regarding the Raoult's law. So if you want, you can solve this. Already solution sameta kottidare, solve madri. After that, see what is the relation between Raoult's law and Henry's law. If you have observed, Henry's law ಏನು ಹೇಳ್ತೈತಿ? P is equal to KH into X. This is Henry's law. But remember, this is for gases in liquids. Gases in liquid solution we use Henry's law. But Raoult's law yadಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? Solids in liquids or liquids in liquids. In all the three cases, solvent is in a liquid form only, but solute is in gaseous here, but here liquid. According to Raoult's law, the vapor pressure of the volatile component is given as P1 is equal to x1 into P01. Howda? In the solution of gas of a liquid, in case of Henry's law, one of the component is so volatile that it exists as a gas. In that case also there are volatile components, but one of the component is so much volatile that it exists in gaseous form, another one will be in liquid form. So we have already seen that the solubility is given by Henry's law. ಯಾವುದಕ್ಕೆ gases in a liquid solution ಗೆ Henry's law use ಮಾಡ್ತೀವಿ. P is equal to KH into X. If we compare both Raoult's law and Henry's law, we have P is equal to KH into X. Here P1 is equal to K1 into X1 into P01. So what is the similarity and what is the difference? Here only KH and P01 are different. Otherwise, partial vapor pressure is directly proportional to mole fraction, as in case of Henry's law also. It can be seen that partial pressure of the volatile component of gas is directly proportional to its mole fraction of the solution. Only the proportionality constant KH differs from P01. Thus, Raoult's law becomes a special case of Henry's law, in which KH becomes a function of or equal to P01. If KH becomes P01, then we can say both the laws are related to each other. It is a special case. Henry's law is special case of Raoult's law anta helbodu. Only difference antandre Henry's law is explained for gaseous solution, that is gases dissolved in liquids, but Raoult's law is for liquids dissolved in liquid or solids dissolved in solids. That's the difference. See, another important case here, so far we have discussed liquids in liquids. As I mentioned, there are two types of solutions. One is liquids in liquids, we have discussed with the help of Raoult's law. Then solids in liquids. Here also liquid is a solvent and the solution will be in liquid phase only, but the solute is solid in nature. When you dissolve solid, volatile solid, imagine that it is also a volatile component. An important class of solution consists of solids dissolved in liquids, for example sodium chloride, glucose and cane sugar in water, or iodine and sulfur in carbon disulfide. Basically, solid is being dissolved in liquid. Some physical properties of these solutions are quite different from those of the pure solvents. Will you agree or not? Starting pure solvent, bari water the property is different from saline water, in which salt is dissolved. Will you agree? Yes, obviously. Yakandre pure water ittantandre adar property ne different, saline water ittandre adar property different. Even the physical properties will vary. Houdilla, because solid is being dissolved in it. So what is the thing happening here? liquids at given temperature gets vaporized and under certain given pressure and conditions there will be establishment of equilibrium. How the equilibrium establishment ಆಗುತ್ತೆ ಅಲ್ಲಿ, and by the exertion of some pressure of the liquid vapors is called vapor pressure. Vapor pressure ಇಷ್ಟೊತ್ತು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಏನು ವೇಪರ್ ಪ್ರೆಷರ್ ಅಂತಂದರೆ, here the pressure exerted by the vapors over the liquid surface of the liquid over the surface is called vapor pressure. Pressure exerted by the vapors over the liquid surface is called vapor pressure. Vapor pressure ಯಾವಾಗ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಅಂಡರ್ ಗಿವನ್ ಟೆಂಪರೇಚರ್ there will be establishment of equilibrium between solution and vapors. ಎರಡು ನಡುವೆ equilibrium establishment ಆಗುತ್ತಾ, then those vapors will exert some pressure and that pressure is called vapor pressure. If we consider two cases, that is pure solvent and a mixed solvent, here the diagram is given. This is pure solvent, this is mixture or solution. This is a pure solvent, this is a mixture or solution. If you observe here, at pure solvent we have at the surface only one type of atoms. Blue color ಅಲ್ಲಿ ತೋರಿಸಿರಲ್ಲ, ಇದು only one type of atoms, that is nothing but pure solvent molecules or atoms or particles. ಯಾಕಂದರೆ ಇದರೊಳಗೆ ಏನು ಮಿಕ್ಸ್ ಆಗಿಲ್ಲ. ಅವಾಗ ಏನಾಗಿರುತ್ತೆ, there will be establishment of equilibrium between these vapors. Consider these as vapors. These as vapors, there will be establishment of equilibrium between this vapors and liquid surface. Here also there is a equilibrium between vapors and liquid surface. This is also vapors only. But if you observe, what is the difference? Here there are more and more molecules or particles of liquid, but here only few particles are there. ಯಾಕೆ ಏನು ಡಿಫ್ರೆನ್ಸ್ ಇರ್ಬೋದು? Here only one type of solvent particles are there, so that number of particles moving into vapor phase will be more and will be equal to the number of particles coming back into liquid phase, so that more and more number of particles will evaporate, more and more number of particles will come to solution state. ಹೋಗ್ತಾ ಇರುತ್ತೆ, ಬರ್ತಾ ಇರುತ್ತೆ, more and more number of particles, it will be like a cycle. But here what happens, since our surface is covered not only with the solvent but also with the solute, green color ಇರೋದೆಲ್ಲ solute particles. Here on the surface only one type of liquid particles are there, but here above the surface there are mixture, both solute and solvent particles will be there. Therefore what happens, the number of solvent molecules going into vapor phase will decrease, obviously decrease ಆಗುತ್ತೆ, and similarly number of vapor particles coming back into solution will also decrease. ಹೋಗ್ತಾ ಇರೋದು ಕಡಿಮೆ ಆಯ್ತು ಅಂದ್ರೆ ಬರ್ತಾ ಇರೋದು ಕಡಿಮೆ ಆಗುತ್ತೆ. So that ultimately what happens, vapor pressure, the pressure exerted by the vapor also gets reduced compared to pure solvent. This is the reason why pure solvent has more vapor pressure compared to the solution. Vapor pressure in pure solvent is more because more and more vapors are available, but here less vapors are available, less pressure is there, therefore vapor pressure is reduced here. The same thing is given. From the surface is correspondingly reduced, thus vapor pressure is also reduced. The decrease in the vapor pressure of the solvent depends upon the nature or the quantity of the non-volatile solute present in the solution. ಅದಕ್ಕೆ ಹೈಲೈಟ್ ಮಾಡಿಟ್ಟಿದ್ದೀನಿ ಇದನ್ನ, the quantity of the non-volatile solute present in the solution ಏನಾಗುತ್ತೆ, if you add more and more solute, here you can easily differentiate. Solute ಕಡಿಮೆ ಇತ್ತು or solute ಇಲ್ಲೇ ಇಲ್ಲ ಅಲ್ಲಿ, only pure solvent is there, therefore vapor pressure is more. You are adding solute here, solid solute here, so that our surface gets accumulated with the solute particles and vapors, number of vapors gets reduced, so that vapor pressure also reduced. If you add more and more solute ಏನಾಗುತ್ತೆ, all these liquid molecules are replaced by vapors, solids, ಹೌದಿಲ್ಲ, solids ಇಂದ replace ಆಗಿಬಿಡುತ್ತೆ, so that number of molecules of solvent going into vapor gets still more reduced. ಅವಾಗ ಏನಾಗ್ಬಿಡುತ್ತೆ, as quantity of solute you are adding increases, vapor pressure decreases. Thus we can say that vapor pressure of solvent depends upon the quantity of non-volatile solute present in the solution, irrespective of its nature. ಯಾವ್ದಾರ ಇರಲಿ, ಕ್ವಾಂಟಿಟಿ ಮೇಲೆ ಅಷ್ಟೇ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅದು. For example, decrease in the vapor pressure of water by adding 1 mole of sucrose to 1 kg of water is nearly same or nearly similar to that produced by adding 1 mole of urea to 1 kg of water. 1 mole urea 1 kg add ಮಾಡಿದ್ರು ವೇಪರ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಇರುತ್ತೆ. 1 mole of sucrose or sugar ಅನ್ನು ವಾಟರ್ಗೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರು ವೇಪರ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಇರುತ್ತೆ. That means it does not depends upon the nature of the solute you are adding, it depends upon the quantity of the solute you are adding. More and more quantity if you are adding, then vapor pressure is reduced. Raoult's law in general form can be stated as: for any solution, the partial pressure, vapor pressure of each volatile component in a solution is directly proportional to its mole fraction. That is the reason for any solution, the partial vapor pressure of each volatile component is directly proportional to mole fraction, to its mole fraction. This is the simplified version of Raoult's law. In a binary solution, let us denote the solvent by 1 and 2 or solute by 2 when the solute is non-volatile. Consider solute is non-volatile. That means solid is non-volatile, liquid is volatile in nature. Only the solvent molecules are present in the vapor phase. Yes or no? Whenever you add solid in liquid, if the solids are non-volatile and solvent or liquid is volatile, then in a vapor phase, what do you expect? Vapor phase ಒಳಗೆ ಯಾವ್ದು ಇರುತ್ತೆ? Volatile means what? Which gets evaporated. ಅಂದರೆ being volatile in nature, only liquids are vaporized but not the solids. ಅವಾಗ ಏನಾಗುತ್ತೆ? The vapor pressure of the solvent in a pure state, then according to Raoult's law, P1 is directly proportional to x1. P1 is equal to x1 into P01. Here, as vapor pressure or mole fraction, as mole fraction of the solvent increases, vapor pressure also increases, because there is a non-volatile solute. So non-volatile solute iddaga we discuss Raoult's law, or Raoult's law applies only for vapors are only from liquids. Therefore mole fraction increases, solvent increases, vapor pressure also increases according to Raoult's law. This is the interpretation of Raoult's law. For today, this much is enough. From next class we shall have discussion on ideal and non-ideal solutions. These are very important topics. As for exam point of view also, we will get fixed questions on that topic. From here also, either in Raoult's law or in Henry's law, we will get fixed questions in both exam patterns. I hope you understood the topic. Still, if you have any queries, make sure to comment below. We will try to make videos on that also. So thanks for watching. Keep sharing this video and keep smiling.